So next couple of things that might affect enzyme speed, rate of reaction. One of them is enzyme concentration. So again, that's directly proportional. So you've got enzyme concentration on here and then rate on here. So all that's saying is the more enzymes you put in, the faster the rate. It doesn't matter how many enzymes you put in. Very high enzyme concentration, it might sort of start to level out a little bit here, but normally, there's not going to be enough enzymes in order for it to do that. And your fourth one is your substrate concentration, and that graph will look a little bit like this. So you've got your substrate concentration here, your rate. So the more substrate you put in at the beginning, the faster the rate, but then it will level off, basically because all the enzymes' active sites are all occupied. So no matter how many more substrate concentration, how many more substrate you put in, it's not going to make any difference. So the last little thing we want to look at is inhibitors. So inhibitors, they will actually, as I say, they'll inhibit the enzyme activity and they'll reduce the rate of the reaction. They're normally found naturally, but they can be used artificially. So you find them in drugs, pesticides, things like that. They bind weakly to the enzyme, so fairly weakly binding, and they can be washed out. They can be cleared out by reverse inhibitors as well. So you've got two types. You've got competitive inhibitors, and they will actually compete for the active site with the substrate. So they'll compete for active site. So they'll be the same shape. They'll be complementary to the enzyme's active site. So there's your enzyme, your substrate like that. I'll want to bind in there, and if it does, happy days. There's your enzyme. There's your substrate, and you'll get your enzyme substrate complex. You got your reaction here. Okay, substrate. An inhibitor that can bind in there as well. So that's inhibitor. And that's essentially the same shape as a substrate. And if that happens, if that happens, you will get an enzyme inhibitor complex. So there's your enzyme, there's your inhibitor, and you'll get an enzyme inhibitor complex, and there will be essentially no reaction. So your rate of reaction will slow down if that is in there. So the next one, if we've got competitive inhibition, we have non-competitive inhibitors. Non-competitive inhibitors. They're quite different in structure to the substrate molecule, and they will not fit the active site. So do not compete with active site. Essentially, what they will do is they will bind to an area that is not the active site, and will basically change the shape of the whole enzyme, including the active site, so that it can no longer bind with the substrate. Changes shape of enzyme, no longer able to bind to substrates. Okay, so it will bind what's called an allosteric site. It will bind somewhere other than. So there's our enzyme. It might bind up here. So there's our inhibitor there. It will change the shape. Let's say change it to that. Change the shape of the enzyme, so there will then be no reaction here. I'll put up another video explaining all this with graphs and things on there. We'll talk a bit more about it in class, but this is basically your basic theory on your inhibitors in the enzyme.